In this lesson, you are going to learn about the mole concept. We are going to see how a mole is taken as a unit of measurement. You have to know that we have various units of measurement, like the unit for the time is seconds, the unit for the distance is meter, the unit for mass is kilogram, and other units. So, from today, you have to know that even a mole is one among the units of measurement. Now, what is a mole? Before I tell you the meaning of a mole, let us start by looking at these figures. We have various items here which are grouped in three parts. We have a first part, a second part, and a third part. Let us start by counting the number of items in the first part. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So we have 36 items. After we have finished to count the items in the first part, let us count the items in the second part. As you see these items, the items in the second part are arranged in various groups, whereby each group has 2 items. Now, to simplify counting the number of items here, because they are arranged in groups of equal number of items, whereby in each group we have 2 items, let us count the number of groups which are present. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 18 groups, and in each group we have 2 items. So how many number of items? We have 2 times 18, which is the same 36. So also we have 36 items. After that, let us see the number of items in a third part. In a third part, when you look across all items, you may find that we have 3 groups. And in each group, there is equal number of items. As let us count the number of items in the first group. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 items in each group, and there are 3 groups. So to know the total number of items, we are not required to count each item. No, you have to take the number of items in one group, which is 12, you multiply to the number of groups, because each group has equal number of items. So it is 12 times 3, whereby we are going to get 36. Now, you may notice something. When the number of items are grouped in 3 groups, whereby each group has 12 items, it became easier to count the number of items than when the items were grouped in 18 groups, whereby each group has 2 items. But also this was simpler than in the first part, whereby the items are arranged in a random way. Now, what do you notice? We notice that when we arrange the items in groups of equal number, it becomes easier to know the total number of items than when the items are arranged in a random manner. For example, when the items were arranged in the groups of 2 items per each, it became easier because you take the number of groups and you multiply to the number of items per each group. So that's why we have counted 18 times, and you have taken that number 18 times 2 because each group has 2 items. Also, when we arranged the items in groups of 12 items per group, we were only required to know how many groups of equal number were there, and we found that the number of groups were 3. That's why we have taken 12 times 3, because each group has 12 items and we have only 3 groups. So from today, to simplify counting, when you group the items in groups of equal number, it becomes easier because you take the number of items per each group times the number of groups. You have to know that when the items are grouped in 2 per each group, we call that is a pair. So one pair is equal to 2 items, and 12 items are taken as a dozen. Now, 1 dozen is equal to 12 items. And you have to know that when we take 12 dozens, we get a gross. So, 1 gross is equal to 12 dozens. Is equal to 12 dozens. Now, how many items are there? Is equal to, as 1 dozen has 12 items, is equal to 12 times 12, whereby you get 144 items. Now, this is the way chemists decided to simplify the process of counting items. So let us come back to our lesson. Our lesson is to know what is a mole. How is a mole used as the unit of measurement? You have to know that chemists sat down and came up with the way we can know the number of particles present in various chemical substances. Now, how did they do to know about 1 mole? They decided to compute the number of atoms present in 12 grams of carbon-12 isotope, and they took that value as the standard number to be used to all substances as the particles present in 1 mole of a substance. So, when we speak about 1 mole of a substance, we refer to the amount of a substance that contains many particulate entities as they are carbon atoms in 12 grams of carbon-12 isotope. So, how did they do to know that number, which they took as the standard unit to be used as the number of particles in 1 mole of a substance? To know the number of carbon atoms in 12 grams of carbon-12 isotope, they took that mass over the mass of a single atom, which I have told you that it was found to be 1.9927 times 10 power negative 23 grams. Now, let us see what did they get in 1 mole of a substance. Now, the number of carbon atoms present in 12 grams of carbon is equal to So, when you take 12 grams over 1.9927 times 10 raised to negative 23 grams, you get 60.022 times 10 raised to 23 atoms. Now, the number of carbon atoms which are found in 12 grams of carbon is equal to 6.022 times 10 raised to 23. And chemists decided to take this as the standard unit to be used as the number of particles present in 1 mole of any substance. These particles can be atoms, molecules, ions, photons, electrons. This number, which was taken as the standard for the number of particles in each mole of a substance, is known as Avogadro's constant, because the one who did this work was an Italian scientist known as Avogadro. So this is also known as Avogadro's constant. So when we speak about Avogadro's constant, which is denoted as RA, is equal to 6.022 times 10 raised to 23 particles. I have written here particles, not atoms, because here I have written atoms as we are dealing with carbon atoms. But when I write particles, I mean that the particle, these particles cannot only be atoms. You may find maybe molecules, ions, so it depends on the question asked. Now, maybe assume someone tells you to calculate the number of atoms present in 3 moles of sodium. Here, to solve this question, you have to know the number of atoms present in 1 mole of sodium. The number of particles present in 1 mole of any substance, as I have told you, that is equal to the Avogadro's constant, which is 6.022 times 10 power 23 particles. As we are given 3 moles of sodium, it is 6.022 times 10 power 23 times 3, because we have now 3 moles, as that value which is Avogadro's constant is for 1 mole. Now let us see the solution for this. So total number of atoms in 3 moles of sodium is equal to 3 times Avogadro's constant, and we get 1.8066 times 10 raised to 24 atoms. Now this is the way we deal with the problems of calculating the number of particles when you are given the number of moles in the particular substance. And we have a generalized formula to relate the number of particles, the number of moles, and Avogadro's constant, whereby we say n, capital letter N, is equal to small letter n times Avogadro's constant, whereby capital letter N represents the number of particles. These can be molecules, atoms, ions, etc. So the number of particles is equal to number of moles times Avogadro's constant. This is the formula used to relate the number of moles and the number of particles with Avogadro's constant. Let us see various examples on how we use this formula that relates number of moles, number of particles, as well as Avogadro's constant. The first example states that how many molecules in 5 moles of nitrogen gas? So let us see the solution for this. We have said that in the generalized formula to relate number of moles, number of particles, and Avogadro's constant, it is, in our question here, we are asking the number of particles. Now, the particles asked here are the molecules. How many are they in 5 moles of nitrogen? So, N is not known. Now, N is not given, which is the number of molecules, as now our particles are molecules. But we are given the number of moles, N. The number of moles given, we have 5 moles. As we know, Avogadro's constant, which is RA, is known. Avogadro's constant now is equal to 60.022 times 10 raised to 23. Now we don't write particles. We have to be specific, as even the question is specific. We are dealing with the molecules. So it is 6.022 times 10 raised to 23 molecules. Now the value of N will be equal to small letter n, which are moles, 5 times Avogadro's constant, which is 60.022 times 10 raised to 23. How many molecules do we get? Let us compute. Here we have 5 times 60.022 times 10 raised to 23. We get 3 is equal to 3.011 times 10 raised to 24. Now these are molecules. This is the answer. Now there are 3.011 times 10 raised to 24 molecules in 5 moles of nitrogen gas. After this example, let us see the second example. The second example states that how many moles present in 4.57 times 10 power 28 atoms of aluminium? Let us see the solution for this. Data given here. N, capital letter N, which stands for the number of particles. Now we are given atoms. We have 4.57 times 10 raised to 28 atoms. What are we asking? We are asking to calculate the number of moles. So small letter n, number of moles, is not known. But we know Avogadro's constant, which is La, is equal to 6.022 times 10 raised to 23. Now we are dealing with the atoms. So it will be atoms. The number of atoms in 1 mole of aluminium. Atoms. So from our formula, we have said that capital letter N is equal to small letter n times La. Now the number of particles is equal to number of moles times Avogadro's constant. So how many moles? Now we are going to find small letter n, number of moles. Now number of moles, when we make small letter n the subject, is equal to number of particles, which are number of atoms, over Avogadro's constant over La. Now the number of moles, small letter n, will be equal to number of particles. We have 4.57 times 10 raised to 28 over Avogadro's constant, which is 6.022 times 10 raised to 23. Now this will be equal to, let us compute this, 8 times 10 raised to 4. These are moles. So the number of moles of aluminium present in 4.57 times 10 raised to 28 atoms is equal to 7.5888 times 10 raised to 4 moles. This is the way we rate the number of particles, number of moles, and Avogadro's constant. If you have enjoyed the lesson, make sure that you share with your friends so as to make them to get the same knowledge. Thank you for today's session. Have a nice moment.